So 9.5, properties of logarithmic functions. We're going to convert from logarithms of products, powers, and quotients to expressions in terms of individual logarithms, and conversely, and simplify expressions of the type log base a to the x, and a log base a to the x. If any number a, for any number a, we agree that a to the 1 means a. You know that. That's not anything new. We know that if we're raising anything to the first power, that we're going to get that back. If we had 100 and we're raising it to the first power, it's 100. Anything that we raise to the 0 power is 1. So if we have 2 to the 0, it's 1. If we have 100 to the 0, it's 1. We talked about why that was in some of the first lessons in chapter 9. The product rule. If you have the same base and you're multiplying, then you're going to add the exponents. So if I had 2 to the 3rd times 2 to the 6th, my base is the same. The trick is that I would do 2 to the 3 plus 6, which is 2 to the 9. That's all that's saying, which we just talked about during our support review. If we're dividing, we subtract. So if I have 2 to the 6th over 2 to the 3rd, then it would be 2 to the 6th minus 3, or 2 to the 3rd. If you're dividing and it's the same base, then you subtract. The power rule, if you've got something raised to the power and then that whole thing's raised to the power, then you take these two exponents and you multiply them together. So 2 to the 3rd squared would be 2 to the 3rd times 2, which is 2 to the 6th. And we use that distributive property when we were describing that. If we have two things raised to a power, then that exponent on the outside of the parentheses has to go with both of the things on the inside of the parentheses. So if I have 2 to the 2x to the 3rd, then I'm going to have to make sure that 3 goes with both of these things. 2 to the 3rd times x to the 3rd, which is what we just got through talking about in support a lot. This kind of breaks down the rules though. If we've got a negative exponent, if it's on the top or we don't have a bottom of the fraction, it gets to move to the bottom. So if I have a to the negative 2, then that's going to be 1 over a squared. The other thing that you need to realize is if you have something like 1 over 3 to the negative 2, well, if the negative exponent's on the bottom, then it would move up to the top and just be 3 squared. So if it's on the bottom of the fraction and it's negative, it's going to move to the top. If it's on the top and it's negative, it moves to the bottom of the fraction. It changes places. If we have a quotient to a power, which is what we did on that last example. So if I have 2 over x and I've got a 3 out here, that 3 has to go with both of these things. So it would be 2 to the 3rd, x to the 3rd. If it's a negative exponent, so I'm using this example. If it's a negative exponent, the first thing that's going to happen is the negative part makes the thing switch places. So I'm going to make the x go to the top and the 2 go to the bottom, and that's going to change it to just being a 3. So I wanted to get rid of that negative part, and switching them from bottom to top got rid of the negative part, but the 3 still has to go with both things. So x to the 3rd, 2 to the 3rd. So those are the properties of exponents kind of in a nutshell. And the reason that we're going over those is because they go really hand in hand with the properties of logarithms. So on an exponent, if you're multiplying an exponent, then they have the same base, you add the exponents. On an exponent, if you're dividing the exponent and it has the same base, you subtract. So the rules go hand in hand with these logarithms that we're looking at next. So right here, you can see that they are multiplying. So to separate them out, multiplication goes with addition. If I have addition and I want to put them back together, I would multiply. just like the exponents that we just got through doing when we were saying, don't write this down, but we were saying x to the, if we had x to the third times x to the second, well, we would say that's x to the 3 plus 2. Well, they're multiplying and they're saying, okay, add. They're multiplying, add. The properties kind of go together. They're similar is what I'm trying to say. Maybe easier to see it there. So on this one, what it's telling you is express it as a sum of logarithms. So that when they say that sum means addition, answer to an addition problem. And right now they're being multiplied. So they're wanting you to stretch it back out and make it be an addition. So you would say the log base 3 of 9 plus the log base 3 of 27. They're telling you, we've got it condensed here. We want you to stretch it back out. And the reason that you want to be able to work with logarithms and know the properties is in a very short amount of time, we're going to have to solve problems using the properties. So this one's already stretched out. They've got the plus here. They're wanting us to express it as a single logarithm. So they're wanting us to squish it back together. So if it's already plus, we're going to put it back together by multiplying it. They both have to have the same index down here. So we've got log base 2. So we put it back together. It's going to be log 2. And then with that little subscript of a 2, and then p to the third times q. I just took my, whatever I was taking the log of and multiplied those together. That's it. So if they're being multiplied, you can stretch it back out by adding them. If they're being added, you can condense it by multiplying them. They go hand in hand. There's another property that says if you're taking the log of something and it's raised to a power, you can take that power and you can move it to the front. When we're solving logarithms, which we will be doing, or we're solving problems involving logarithms, which we'll be doing in the next class, this property is real important. Okay, so all they're wanting you to do here is say, if you got the log base a of 11 to the negative third, they're wanting you to take that exponent, they're wanting you to move it in the front and rewrite it as -3 times the log base a of 11. That's all we're doing there, is that there's a property that says if you've got a log and it's raised to the power, you can move the power in the front. That's why it's called the power rule. Okay, I need to remind you that if you have the square root of x, that means the same thing as x to the 1/2, because this is we know this is the square root. And so these two statements mean the same thing. If I said the cube root of x, that's the same thing as x to the 1/3. If I say the 4th root of x, I could rewrite that as x to the 1/4. They mean the same thing. They're the same property. I don't know why I put a line there. Sorry. It's just supposed to be the 4th root of x. So the 5th root of x would be x to the 1/5. Those things go together. They mean the same thing. So right here, you're like, well, how am I going to use the product rule on this one or the power rule? There's not even an exponent here. Well, you got to make it have an exponent. So I could rewrite this as the log base a of 7 to the 1/4, because we're taking the 4th root. You can raise it to the 1/4. That's what that means. Everybody okay with that? So that 1/4 would come to the front. So 1/4 log base a of 7. This one's not bad. The natural log of x to the 6. What's the base here if they don't put 1? E. If it's a natural log, it's an E. If it's log and there's no base, it's 10 if they don't put 1. Right? Natural log goes with that little letter E. So the 6 would come to the front. So we would say 6 natural log of x. You don't have to put the E there. It's just understood that it is that. And that looks like 61. So let me stick a little curl on my L there. Maybe that will help. Okay. The power rule just says if you have anything in the front or anything raised to a power, you can move that power in the front of the log. if I had x to the third over x squared, then we're dividing, then we said subtract, right? It's the same thing. If you're dividing, then you could stretch it out by subtracting. If you're subtracting and you want to put it back together, you can divide. So on this one, we're dividing and they want us to express it as a sum of, or as the differences. So that means they want us to stretch it back out and make it be a subtraction. But they both have the base, those subscripts of t down there. This one, they're saying, go the opposite direction, express it as a single logarithm. So if we're subtracting and we want to put it back together, we're going to make it into a division, 64 over 16. And that log looks like it's on the bottom, but I really just mean it to be out in front, like log base b of this whole thing. Does that make sense? Okay. And we could figure out what 64 over 16, which is 4, we could put that, but that's not what they're trying to get to here. We're just working with stretching them out, putting them back together. So addition goes with multiplication. Multiplication goes with addition. The power rule says if you raise something to the power, you can move it to the front. Division goes with subtraction. Subtraction goes with division. Okay, so we've got to use those here. You've got this paper in front of you, and so the people that are following online, I know can see this too, but they're in color here, so it's a little bit difficult to see. I'm going to write this. All I'm doing is rewriting the problem. So we've got the log base a of x squared y to the 5th over z to the 4th. On the top of this, we've got multiplication going on, right? We've got x squared times y to the 5th. What does multiplication go with? Addition, right? For multiplying, we can add, okay? Then on the bottom, a fraction is just a fancy division problem. So we're saying multiply x squared times y to the 5th and then divide this fraction bar by z to the 4th. And subtraction goes with, division goes with subtraction. Okay, so here's what we're doing. The first thing I'm dealing with is the multiplication on the top. They're wanting me to express this as sums and differences. So I am stretching the top back out and saying, well, if I talk about just the top, we're multiplying, so we could break that x squared and y to the 5th up into an addition problem. Then we are dividing by z to the 4th. Dividing means subtract. So we're dividing by the log base a of z to the 4th. So that would be a subtraction. Does that make sense so far? Okay, we're multiplying on the top, and I put it in parentheses. This time we really didn't need to put it in parentheses, but if you get in that habit, it'll keep you from making mistakes. There's nothing in front of this parentheses here, so I could just write the log base a of x. The 2 needs to go where? I'm not going to take care of that one step, but I think some of you are smart enough to do that. This minus does need to go with whatever's behind here. So the log base a of z to the 4th. So the last thing I can do is say 2 log base a of x, because the 2 can move in the front. That power rule, plus 5, this 5 can move to the front. Log base a of y, minus this 4 can move to the front. 4 log base a of z. We halfway okay with that? Okay. And like I said, we're fixing to break this down and go over our homework together. So it should slow it down and then speed it back up enough where I think you're going to be successful with it. Okay, so this one has a multiplication on the top and a multiplication on the bottom, right? And then in the middle, it has a division. So I know division is subtraction. I know that I'm going to have to add something because I have a multiplication on the top and I have a multiplication on the bottom. And in the middle of the two multiplications, I have a division. So that's why there's a subtraction there. So multiplication means that we are going to add log base b of a and the log base b of y to the fifth. So I just took care of that top part. Then I know I'm subtracting, but I'm subtracting everything on the bottom. So that's why I put it in parentheses. It is going to matter this time. The log base b of m to the third, and then the log base b of n to the fourth. Since we're multiplying those, we would add them. Okay. There, everybody good with that? There is nothing in front of this parentheses here for me to distribute, so I can just remove that parentheses. But this parentheses has a minus in front of it, which means that that minus needs to get distributed to both of those things. Okay. If you don't put it in parentheses, that's one of the times you'll get it wrong, because we're dividing by everything on the bottom, not just the m to the third. So we want to go ahead and put the whole thing in parentheses. What's the last thing I need to do? That power rule, if I've got anything raised to a power, I need to move that in front. This first one doesn't have anything. It's just a to the first. But this 5 needs to come up here. This 3 needs to come in front. So -3 log base b of m. And this 4 needs to come in front. So -4 log base b of n. Okay. So we've stretched them apart. Now they're telling us, first off, anybody have questions so far? Okay. We've stretched them apart. Now it's telling us go back and squish them back together. So they're given one that's stretched apart and they're saying put it back together. What does a minus mean I'm going to do? I got to divide something, right? So I got a minus. So that's the first thing I'm going to mess with. I need to divide something. It's telling me to divide these two things. So they're both log base b. Just going to deal with it. So log base b. This 5 would go back up with the as an exponent. Can y'all give me that one? We can put that back up there. Okay, this y doesn't have an exponent because it's just there's no number in front of the log. So wow. We are adding. So adding goes with multiplication, right? So now we need to say times, right? We're multiplying by something. The 1/4 would go back up with the z. And so we're multiplying by z to the 1/4. And when you kind of put those things together, it would be the log base b of x to the 5th. Z to the 1/4 doesn't have anything on the bottom of that. So it's just, and this doesn't look right because this is supposed to be just in front of this whole thing. It's not on the bottom or the top. It's just in the front. Does that make sense? I don't want to confuse you. Okay, we good? I imagine that you're not good at this point with a little bit of this, but we are going to slow it down here in just a minute and help with that part. This says express this as a single logarithm. We have a subtraction, which means this is division, right? Subtraction automatically means division. These are natural logs, so the base is automatically an e. We don't have to put that, but it has the same base because it's a natural log, so it's automatically a b. I mean an e, sorry. So all I'm doing is we're subtracting, so we're dividing. And we just did this. This is one of the reasons why they ask you to do this on the support, They're wanting you to see if anything will factor out. There's not anything on the top I could factor out, but if I use the quad program here, it would tell me my zeros. And my zeros end up being A is 3, B is -5, and C is -2. And so it's telling me that my zeros are 2 and -1/3. And so if I want to go backwards, the 2 would be x minus 2, right? And then the -1/3 would be 3x plus 1. Y'all remember from doing that from the last unit a whole bunch. Okay, so now I can say, oh, a 3x plus 1 and 3x plus 1, that cancels out. So I'd have the natural log of 1 over x minus 2. If you are following on Zoom, if I write down the natural log of 32, what automatically is the base? What goes right here? If I write down the log of 32, so it should be give me 2 answers in the chat. What's the base right here? This natural log, everybody, what goes right there? Automatically, right? If it's the log and they don't put another number there, it's automatically a 10. Okay, we'll just go back over that. So I told you the answer, so hopefully y'all will put that down in the chat. So it's E and 10. People on Zoom, E and 10. This kind of goes over and gives you a summary of the rules. Okay, now, so that is 9.5. If you are needing more help with this, please make sure you go look at the video that goes over your homework, because I'm fixing to break this back down.